This is today another video. Your body versus implants. Insulin pumps improved the lives of many of the 450 million people with diabetes around the world. By monitoring blood sugar, delivering insulin, and preventing needs for constant finger prickings and blood testing. These small machines include a pump and needle, which can sense glucose levels, feed back to the pump, and it calculates how much insulin to deliver through the needle. But they have a catch. They are temporary. Within a few days, glucose sensors have to be moved and replaced. And it's not just glucose monitor and the insulin pumps that have this problem, but all bodily implants of different time scale. Plastic prosthetic knee has to be replaced over about 20 years. Other implants, such as those for cosmetic reasons, can meet the same fate in about 10. That is just an interest. It can be expensive and risky. These inconveniences happen because of our body immune systems. Honed by several hundred million years of evolution, these defensive responses can be exceptionally good as identified foreign objects. Our immune system boasts an impressive arsenal of tools to tackle, instance, and destroy anything they believe should be there. But the concept of this content surveillance is all bodies with healthy implants like insulin pumps, with the same substance as they would a harmful virus or bacteria. As soon as the insulin pump has been planted in the skin, its presence triggers what is known as a foreign body response. These start with the free-floating proteins that stick themselves to the surface of the implant. Those proteins include antibodies, which attempt to neutralize the new object, and sends the signal to call other immune cells to the site to strengthen the attack. Early response inflammatory cells like the neutrophil cell macrophage responds to emergent cells called neutrophil release lysosomes filled with enzymes that try to break down the surface of the insulin pump's needle. Macrophage secretes enzymes too, together with nitric oxide radical, which create a chemical reaction that degrades objects over the time. If the macrophage was unable to dispatch the foreign body rapidly, they fused together, forming a mass of cells called a giant cell. At the same time, cells called fibroblasts traveled to the site and began to deposit layers of the dense connective tissues. Those increased the needle that the pump uses to deliver insulin and test for glucose level. Over time, these scaffolds built up, forming a scar around the implant. The scar functions as an almost impenetrable wall that might start to block the vital interaction between the body and the implant. For example, scarring around the pacemaker can interrupt the electrical transmission that is crucial for their functioning. Since as knee joints making off the particles that warm down, causing immune cells to flame around these fragments. Directly, the immune system attacks can even be life-threatening. However, research and find ways to track the immune system to accepting new devices we introduce our body tissues. We just covered the cut implants with certain chemicals and drugs can damage immune response. Those basically make the implants invisible to the immune system. We are also making more implants out of nut material and it forms that directly mimic tissue. Thus the body launches a weak attack that would if it came across the complete artificial implant. Some medical treatments involve implants designed to regenerate loss of damaged tissues. In those cases, we can design implants to contain ingredients that will release specific signals and carefully tailor our body's immune reactions. In the future, this way to working alongside the immune system could help us develop complete artificial organs, totally interventive processes, and self-healing wound therapies. These treatments might one day revolutionize medicine and transform forever the bodies we live in.